via the chat. So welcome everybody to our October meeting of the BSA Codes Committee. I am Tara Kolescu, one of the co-chairs of the committee. We also have Drake Jacobs, who was our longtime co-chair. Now I think we're calling him our co-chair emeritus. So welcome. A few brief housekeeping notes if this is your first meeting. Please keep your mic muted for the duration until we have open questions at the end. We do have CEUs available today, and these are going to be administered through the BSA. The link to the Google form can be found in the chat, and I'll kind of repost that periodically just to kind of make sure that people who may join later have that available. One thing to note, there is a field in the end of the Google form for your email address. Please only complete that if you are not a member and are still requesting a certificate. If you're an AIA member, you can just ignore that field. If you have a question at any point through today's meeting, please direct it through the chat. And then when there's a natural pause with our speakers, we'll introduce the question then, or just hang on to it until the end of the meeting. So our meetings typically open with John Nunnery, who is the Executive Director of AIA Mass, and I see that John is present this morning. So he is here to give us an update on all matters from the BBRS and State House. So with that, please take it away, John.
Thank you. Good morning, all. Hope everybody is well. We'll start with BBRS updates. BBRS met last Tuesday, I believe it was, in their normal monthly meeting. Meeting was sort of a typical meeting, but one of the biggest issues or items that they got to in their review of the 10th edition was Department of Energy Resources submitted their proposed amendments to the 2021 IECC. They did not, however, submit a proposal for a new stretch code, or not that they need to submit the second item, but they also did not submit the new municipal opt-in stretch energy code, or what they're planning for that. Again, there is no need for DOER to submit that to the BBRS. The only two items they have to submit to the BBRS are the proposed amendments to the 10th edition, or to the base energy code, and the stretch energy code. So with that said, I'll start with a big overview of what's being proposed for the commercial code and the residential code in terms of the changes that were discussed in or as proposed by DOER. I'll start on the commercial side of the equation. The changes, essentially, there are essentially 7 big kind of moves, if you will, or 8 big moves that they're looking to make on the commercial side. So the first would be to allow the stretch code and the IECC, or the 2021 IECC zero energy appendices, as optional compliance paths. So that would be item 1. Item 2, they're proposing to remove the Massachusetts source energy hash rate performance option and revert it back to the existing site energy approach. The third item would be to modify the envelope backstop to allow use of vertical UA calculations and change the formula. Number 4 would be to reduce the commercial fenestration U values and bring them closer to residential levels. 5 would be to modify the commercial EV ready wiring to 10%, or to bump it up to 10% of spaces with some exceptions. Next would be C406, or section C406 would shift from 3 options out of 10 choices to a point system, and the points would be 15 points from that table. The IECC 2021 requires 10 points, so DOER is proposing 15. The next item would be to maximize the HERS rating option update from 55 to 52, with incentives for electric heat and PV retained for residential low-rise. And lastly, the passive house option is updated from the 2018 to the 2021 standards. The ERI option is updated to reflect new HERS levels under the 2021 IECC. Moving over to the residential side of the equation, the changes are similar, a couple less, but similar. They would allow the stretch energy code as an optional compliance path. They would modify the EV ready wiring to 1 space per home or 10% of multifamily spaces, again, with some exceptions. The HERS rating option would update, again, going from ERI of 55 minus 5% to a HERS rating of 52, and they're simplifying the language. They propose to simplify the HERS rating incentives for clean energy, which is found in table R406.5. The, again, passive house option is updated from 2018 to the 2021 standard. Energy Star Homes 3.1 option is being dropped, pending the 4.0 or the 4.0 option in the future code, which is what's being contemplated. And then lastly, simplification of the new section 408 optional requirements. So that's the big overview of what was presented to the board. The board heard all of those proposals. Quite frankly, the board didn't push back on any of the particular proposals. I think they found the proposals acceptable. What they're in the process of doing, the board did not take a vote to move the proposals forward. Simply because during the conversation, it was pointed out there were some typos in a variety of different sections that DOER wanted to have an option to correct before they get made public. So what is scheduled to happen is at the November BBRS meeting, which will be a public hearing, the board will vote on the DOER proposed amendments. And essentially what the board vote is to say, this is what we would like to move forward with, and they will put them up on the state's website so that the public can view them. Again, there will be plenty of time for the public to review these and add comments or add their comments. The vote that the BBRS is taking is just to say, essentially, that we accept what DOER has proposed, and the BBRS accepts that and is proposing what DOER is saying as the base code amendments to the 2021 IECC. But again, we're a long way off from any of that being finalized. So there'll be plenty of opportunities for the architectural and engineering and anyone else to weigh in on those options. They then turn their attentions to some of the remaining chapters, chapters 1, 3, 4, 5, 10, 28, 31, 32, 33, and a 110.R5. Unfortunately, all they got through was chapter 1, and the board did vote to post the chapter 1, both the IBC and the IRC proposals to the website. And they will get to the review of those remaining chapters, hopefully at the November public hearing. And really, that was about it. That was the big moves, if you will, that were made at the BBRS meeting last week. So I'll stop there and just ask if there are any questions, thoughts, comments, concerns, and then I'll switch over to the legislature. Looks like Eric Peterson.
Yeah, hi. Can you just very quickly update us on when you think the 10th edition is going to be promulgated again?
Sure. So there's no guarantee of anything, obviously, but it appears as though they are still on track to, by basically next fall, to have finalized the entire voting process to the point where they've had the public hearings. The board takes its final vote to say, this is it, this is the 10th edition. Hopefully that will be sent to the Secretary of State sometime around this time next year, with the hope that the 10th edition will be promulgated and on the streets ready for use somewhere around the beginning, January-ish of 2023. So that's the date that they've always been working on. That's the date they're still committed to. So that's the date I would tell everybody to expect, that somewhere around January 2023, not 2022. Somewhere around January 2023, the 10th edition will be promulgated. We'll be in that 6-month concurrency period between the old 9th edition and the new 10th edition. But again, basically about a year from now. Does that answer the question?
Yes, thank you very much. Appreciate it.
John, I sent a note through the chat, but I'll just put it here. You keep really good notes in your attending these meetings.
Mhm.
Can you share some of that? Because keeping track of you as you're reading it off is a little bit more of an exercise than most of us can keep up with you.
Sure.
But if you could share your notes with us, that'd be really wonderful.
I can, and I have. I've sent them to Terica and Andy, and actually even you, Drake. So check your email because you do have them. And I leave it to you guys to decide how you want to distribute them. What I will note, though, is that the actual code proposals, which are included in the notes that I've sent, are not public documents yet. Because the BBRS has not actually voted on them. So what I would suggest at the moment is, if you're going to share anything, just share the highlights that I went through, which I just read right off the screen. I know Terica and Andy, in that email, it's all there, so feel free to pass that along. Again, the actual proposals will be voted on at the November meeting of the BBRS, and they'll vote to make them public and put them up on the BBRS's website so anybody can view them. Again, the real reason that I haven't really truly made them public is because, again, there's a lot of typos that were identified during the meeting, and DOER really wanted to take the opportunity to fix the typos before they made them public. Mainly because most of the board members said it would be worth doing, because what they are trying to avoid is getting 50 comments that say, you've got a typo in this line, it should be table 4.4 instead of 4.2. So, but with that, absolutely. And if it would help, I don't know, I'll leave it to you, Terica. I can copy and paste them and put them in the chat, the highlights, if that would help.
I think instead of that, just so it'd be less work for you, I would say that if anybody is interested in having a copy of these notes, maybe send a message in the chat just to me, and then I can forward on John's email.
Perfect. Any other questions on the BBRS? And what's one other item to note, and this is more of a, I guess, a public service announcement, if you will. I did forward this also to Terica. Paul Sullivan, Paul Sullivan, who is the current chief of inspections, serves on the board, is going to be retiring in December. So the Division of Licensure has put out an advertisement for anybody who would be interested in serving or applying for the chief of inspections position within the state. They've modified, I believe, the roles and responsibilities of the chief of inspections, but in essence, the chief of inspections is the head of the state inspectors as it relates to buildings, mechanical, plumbing, and there's another board that they're overseeing. It's not electrical, but they're the head of the state inspectors in that regard. They sit on the board of the BBRS. They have authority over amusement park devices. And long and short, they're looking for somebody to fill this position. And it would be great, quite frankly, if we found somebody within the A&E industry that understood codes and would be willing to step into that position. Most of you know Rob Anderson. Rob was the longtime chief of inspections, somebody very knowledgeable about building codes and always very approachable. Paul came in when Rob retired, and Paul is a great guy, but by his own admission, is not a building code guy. Doesn't really know the code all that well, and really relies more on Dan Walsh to resolve actual code issues. Paul is much more of a true administrator. So it'd be great if we could get somebody into that position that actually has some, a good depth of technical knowledge, because again, they are the head of the state inspectors, and as you all know, the first stop on any construction site when there is a conflict or an issue between design professionals and contractors, or design professionals, contractors with building officials or building official interpretations, your first stop is to the state inspectors for an appeal before you go to the building board or to the building appeals board. So having somebody in that position that is knowledgeable about what we do, understands codes, I think is quite important. So if any of you have any thoughts or suggestions or ideas, again, the posting is open. It's up on the state's website. So if anybody's interested or has candidates that they think might be interested, please encourage them to apply. That's the public service announcement portion of the BBRS meeting. Unless there are any other questions on the BBRS, I will move over quickly to the legislature. So are there any other questions on what the BBRS is up to and what's happening with the building and energy codes? No? Okay. On the legislative side of the equation, they are the issues for the legislature to resolve are beginning to stack up, but the timing of the issues is really what's taking precedent. So you are probably seeing, if you look at the globe, that the House and Senate this week will be having formal sessions. The House will have their formal tomorrow, and I believe the Senate will have theirs sometime next week. But the big issue du jour is redistricting. Based on the centennial census, the redistricting lines have been proposed. On the House side of the equation, they are moving from 20 minority majority districts to a proposal of 33 minority majority districts. On the Senate side, they're proposing to move from 3 minority majority districts to 6. Obviously, this is a move to ensure that the Black, Latino, or colored, if you will, population have actual representation at the State House. One of the complaints has been that 40% of the state is considered minority, but 84% of our legislature is old white men. So there's clearly a discrepancy and a disparity, and the legislature is looking to address that. Because of the peculiarity of House rules, House members are required to live in their district for at least 1 year before they can run, which is why the legislature is trying to wrap up their votes on the districting maps by next week, so as to allow House members to actually live in their new districts for at least a year before next year's elections. That has been taking up the bandwidth in the legislature. Last week, they sort of punted on funds, what to do with the surplus funds. So the state is in the envious position, if you will, of they still have approximately $4.8 billion in ARPA funding. That's the federal funding related to COVID. They had about $5 billion. They spent some of it on Chelsea and Everett, and I think it was Lawrence, to address some disparities there in funding. But they have $4.8 billion left, and the legislature has decided to set that aside. The House Speaker has indicated that the House or that the legislature will look to spend some of those funds before they take their break at the end of November. In addition to the $4.8 billion, the state also had a $5 billion fiscal year surplus. So while they went into last fiscal year pretty conservatively, and then the pandemic came, and they were very scared as to what that would mean. Oddly enough, the state ended up $5 billion ahead. So rather than spending that money, what the legislature did last week was they passed their closeout budget, which they have to do a closeout budget by October 31st of every year, so that the state comptroller can close the books on the fiscal year. And essentially what they did was they paid their bills and then took the surplus cash that was remaining and essentially put it in an escrow account so that they could deal with it later. What the legislature is essentially saying is, yes, we have 4.8 billion in ARPA funds, and we have a surplus of about 5 billion. So they had approximately $10 billion to play with. And what they've decided to do essentially is watch Congress. What Senate President Spilka said recently last week was that what the state does not want to do is commit those funds and then find out that Congress decided to give us more funds on exactly those areas where the state decided to spend their ARPA funds or the surplus funds. So it's a little bit of a cat and mouse game. They want to see what Congress is going to do on the infrastructure package, if and when we get an infrastructure package, and same thing as it applies to the $3.5 trillion social spending package, which now appears to be more like a $1.5 to $1.9 trillion social spending package. They're looking to get all of that wrapped up, I believe, by December, to try to have the votes to pass that by December. So I think the legislature wants to say, well, we, as the state legislature, will go on break at the end of November. They won't be back until January. I think they hope that Congress in December will pass whatever they're going to pass, which would give the legislature a feeling or an understanding of what kind of money they have to play with, spend that money as it relates to infrastructure and social spending, and then take the ARPA funding and the state surplus funding and supplement. So those are kind of the biggest moves that are being discussed. And then I would say probably the third item and fourth item would be they're still looking at healthcare and maybe doing a healthcare bill. And there will still likely be a climate change bill, a second climate change bill. But it appears as though that this second climate change bill will focus a lot more on offshore wind and production and distribution of renewable energy, more than I suspect it's going to focus on anything related to the building code or the way we construct our buildings. But that being said, another PSA announcement, the November meeting of the Government Affairs Committee, which you will all receive our first announcement on that meeting will go out today. But we meet the second Wednesday of every month, and at our November meeting, we're going to be hosting the House Chairman of the Joint Committee of Telecommunications, Utilities, and Energies. His name is Representative Jeff Roy. He's from Franklin. He's the new House Chair, and it is the Joint Committee on Telecommunications, Utilities, and Energy that is responsible for writing the new climate bill that I just discussed. So he will be our guest speaker. We will be able to talk with him about what his thoughts are on renewable energy, on offshore wind, and more specifically, whether he envisions, again, any further changes to either the BBRS or DOER or anything else related to the world in which we work as it relates to the design and construction of buildings. So that should be an interesting conversation, and I encourage you all to attend if you have interest. With that, I see it's 8:32, so I want to keep you guys keep you on schedule for your presentation. So I'll stop there, and if there are any questions.
Yeah, John, I have one question, kind of a political hot potato.
Sure.
Some of the communities have elected to restrict or prohibit the use of fossil fuels in their jurisdictions. And I think some of this is starting to have some unintended consequences. We're seeing it across the country. The move away through government fiat to move away from the use of oil and coal and gas is now driving up the cost of those utilities, because the producers are seeing a major decline in their markets, but there's no substitute for those products for a great many people. For example, I use oil for heating in my house. Switching over to electrical is possible, but well, what we're going to see then is what we're already seeing is major increases in oil and gas and gasoline. So what do you see going on in relating to that?
Well, there is I mean, if you read the Globe today, for instance, there was a front page story about folks in Springfield who are quite upset that Eversource is looking to essentially build a new gas line. That would be a redundant line with a new substation. And this new line has been in discussion for quite a few years, I think probably close to 10 years now. And there's a big debate. We just passed a massive climate bill in January that obligates the state to cut its emissions by 50% by 2030 and to be net zero by 2050. So there's a large argument saying, why in the world would the state allow Eversource, which will need state's approval to actually build this line, why would the state allow Eversource to invest money, which by building this line, they get a fee on Eversource's charges for new construction. So they get to up the amount that they charge customers based on this assessment that's allowed per state law for capital improvements. Why would they do that when the state is obliging itself in the next 10 years to cut its greenhouse gas emissions by 50%? Why not move to take that money that is going to be spent, as the example in the article points out, to build up its reserves of electric supply and, for instance, supply electric heaters to everybody in Springfield instead of allowing gas to be pumped, or more gas to be pumped. I know that Senator Barrett, who is Rep. Roy's counterpart, is the loudest of squeaky wheels within the legislature on this. He's dead set against allowing Eversource to move forward with something like this. And what I can say I know is one of the conversations that is occurring, but the details of which I quite frankly don't have a lot of information on, is there appears to be, or there's an argument that there needs to be this sort of fine balance. Groups like, or I shouldn't say groups like, but a lot of the environmental organizations are arguing that we need to shift immediately. We need to stop gas production. If it were up to most of the environmentals, they would just literally shut off gas production and force utilities into moving to clean renewable sources immediately, which makes sense, and it's a good political argument, but it doesn't take into account the realities of the way we all live. So for instance, Drake, you just mentioned your house is still heated on oil. Now, arguably, as a white collar professional who is not new to the workforce, there's an argument that says you're in a better position to be able to take advantage of mass save if you wanted to switch your home over to all electric, if that was your choice. But not everybody in the state, quite frankly, has that ability. As was noted, over 48% of the state is considered minority. And as we all know through our EDI discussions, a lot of the minority communities are the ones that are most affected by climate change and are in the position of being least able to take advantages of changes or switches from oil to electric or from gas to electric. So there has to be a understanding that over the next 10 years, we're going to have to wean ourselves off of fossil fuels, but it's going to come with growing pains. And as much as I know the environmental community and quite frankly, the IPCC report says we need to stop today. The gas spigots should just be shut off. We should not be pumping oil out of our oil rigs out in the ocean anymore. It should all just stop and move to solar or wind or any other renewable source. But that comes smack up data against the reality of the reality is that we don't have enough renewable energy sources online, either in the state of Massachusetts or even across this country, to just go cold turkey and shut everything off. So it will be a political football and a bit of a fight over the next 10 years of how do we do that? I don't have the answer to that question. And quite frankly, that might be a question for Rep. Roy next month to talk about the transition process. What is it going to be? What is it going to look like? How do we do this? It's one thing for the legislature to do what it did and say every 5 years the state has to say, here's how much greenhouse gas we're going to be reducing in big sectors. So the building sector is going to have to reduce by X. The transportation sector is going to have to reduce by X. But the rubber is going to meet the road in terms of how do we actually do that? What does that actually look like on the ground? What does that mean not only for our profession, but for your own wallet in your own home? I don't have answers to those questions, but it is an ongoing conversation. So I'm sorry to answer your question with an answer, Drake, or with a question, but that's the best that I have.
Fair enough, John. I guess the real issue, as you were just saying, is that there's a balancing act. We have a very large housing stock, and there's a very significant percentage of it that is not equipped to do the switchover at this point in time. And many of the people living in those facilities they don't have deep pockets. And so going out and spending the money to make a switchover is just not in the cards. So if the fuel source is significantly changed in a draconian manner, there are a lot of people who are going to be hurting.
Yeah.
And I think we already see it in terms of just those of us who from time to time have to go for a drive in our lumbering machines. That price is also skyrocketing.
Yeah, and it's also, it's not just finance. It's also, for instance, I live in a house built in 1871. So I could absolutely switch it from gas to electric. I could put solar panels on it and go full on electric, but I still live in a house that's 150 years old and leaks like a sieve. So, granted, yes, I could put solar panels on and in theory, hopefully produce more energy than I need. So even though I have to crank up the heat in the middle of the winter just to keep the house warm because there's no way to put insulation in these walls, the argument, I suppose, is, well, the electricity I'm generating is free because it's coming from the sun and doesn't have greenhouse gas emissions, but doesn't really counter the fact that I have to, burn probably twice as much electricity to keep the electric heat on to keep the house at a temperature that's, livable. So, there's all sorts of issues and all sorts of problems that will have to be resolved or have to be thought through. And again, there's going to be growing pains. Not everybody is going to like what's happening, but if we all bought into the idea that, and certainly the legislature has, and I would say that the vast majority of AIA membership has bought into the philosophy that yes, greenhouse gas emissions are a problem. They're causing climate change. The IPCC reports are to be believed, and we're on a trajectory that if we don't take action within the next 10 years, likely none of us on this call are going to see the most dire consequences of climate change, but our kids will, and certainly their kids will. So it's something that has to be addressed, and it'll be a sticky, uncomfortable conversation, but one that the globe has to undertake. With that, again, it's 8:42, so I know you want to get going on your other topics. So unless there's any other questions, I'll turn it back to you guys.
All righty, I don't see anything in the chat. So for those of you who joined maybe a little bit later, welcome to our October BSA Codes Committee meeting. We're excited today to have Don Contois and Sam Sinapi from RW Sullivan here to present to us on code considerations relative to hazardous materials and labs, with a particular focus on existing building conversions. So As a reminder, the CEU link can be found in the chat. I will go ahead and post that again now. Please direct your questions to the chat. When we get to a natural pause, we will bring them up. And if there isn't a good time, then certainly we can have questions at the end. And Don and Sam are going to be sharing the PDF with us, and we'll also have the recording available on the Codes Committee website. So with that, Don and Sam, please take it away.
Thanks, Tarika. Recognize a bunch of names on the participation list, so participants list, so that's good to see. For those who don't know me, I'm Don Contois from RW Sullivan, and with me is my colleague Sam Sinapi, who has worked with me on quite a bit of these lab conversion projects lately. It seems like, you know, after the pandemic, because of the ongoing pandemic, you know, we're seeing a lot of office buildings at least investigating the idea of moving to lab rather than just basic standard office space. I think people found that they can work remotely a little bit easier than maybe previously anticipated. So it seems like office space may not be as needed in the future. So I definitely see a lot of these building owners and developers moving towards at least investigating converting to, you know, lab space within their building. Just a quick summary of RW Sullivan, the company we work for. We have just under 100 employees. Started off as a plumbing engineering firm back in 1945 and has grown significantly to essentially cover all MEP trades as well as co-consulting. A little bit on what we do. What you typically expect from a co-consultant: building, fire, life safety reviews, plan reviews, existing building reviews. You know, we've assisted with variances and appeals, and we've worked now, you know, primarily in the Northeast, but obviously definitely do national work and certainly a couple international projects under our belt. It seems like most places have gone to some form of the IBC, so it has made it a little easier to work, you know, throughout the country anyway. In addition to code, because of the engineering side of things, we offer, you know, we're familiar with Revit, you know, have, you know, people within the firm that can help with sustainability lead questions, hazardous materials, obviously, which is going to be a key component of today's presentation, and then, you know, kind of assisting with evaluating for structural fire resistance and some alternatives. So to jump in to the presentation, what we'll be talking about today are the applicable codes with regards to, you know, lab buildings, discussing existing building requirements, and then getting into the lab specific requirements such as hazardous materials, building code compliance strategies such as, you know, exempt quantities, control areas, and, you know, use group H, high hazard uses if you have a large amount of chemicals. Talk about some of the NFPA standards that apply to it, the mechanical code implications, plumbing code in terms of drainage and how you handle some of that hazardous waste. And then we did add some slides on the 2021 IBC and NFPA 45. Some of the, you know, changes, they weren't, there's one significant change for higher education in the 2021 IBC, but other than that, most of the changes were, you know, relatively detailed or minimal. But we will touch on that because that would be the basis of the 10th edition, and as John just explained, potentially will be in effect in about a little over a year. So currently, the applicable codes that would apply to, you know, a project is obviously the Mass Building Code 780 CMR, 527 CMR1, which is the Comprehensive Fire Safety Code, which adopts and amends NFPA 1, the Mass Plumbing Code, and then as part of the Building Code, obviously we adopt the International Building Code, the International Existing Building Code, the 2015 editions. The Fire Code, we're referenced by the Building Code specifically, as well as the Mechanical Code. And then with by the Fire Safety Code, NFPA 1, which adopts NFPA 1 specifically and amends it, it also then references NFPA 30, 45, 55, 70 is the Electrical Code, and then NFPA 704, which is essentially those diamonds that you see on buildings and spaces that have hazardous materials that give the fire department an idea of what's in the room and how hazardous it is. So just we have some slides kind of basically on the existing building code and how it applies. This is somewhat general at the beginning. It would apply to any existing building project, but within 780 CMR Chapter 34, they delete the IBC Chapter 34 and replace it with an adoption of the existing international existing building code. And then Chapter 34 has the amendments to that code. And within that, or as part of the mass amendments, any IEBC provisions generally related to electrical, plumbing, and accessibility are deleted, similar to the rest of the code, where it's replaced by the mass specific CMR, such as the plumbing code 248 CMR and the accessibility code, etc. So when you're working within an existing building, that's the place you really want to start, is to go to Chapter 34 in the IEBC, and that'll really dictate the scoping that applies applies to your project based on your renovation. You certainly don't want to jump into essentially chapters 1 through 33 necessarily right away, unless you're directed to by the existing building code. We see that happen quite a bit, and both on the building official side as well as the design side. We see a lot of attempts to either enforce or try to comply with the code for new construction, which may not be necessary based on the scope of the project. So when you're working within the international existing building code, it does give the designer 3 potential options of methods to comply with the code. There's a prescriptive compliance method, which essentially says all your new work, your additions, alterations, or repairs have to comply with new construction, and then elements of the building that aren't altered would generally be allowed to remain. It's a very vague section. It doesn't provide much guidance or many exceptions, so we tend to not use the prescriptive compliance method, except for like a relatively new building where we know it's generally already compliant, and we would make the new construction has to comply no matter what. So that would be one time we would use that method. The most common method we've seen used, and we generally use on our projects that we provide consulting on, is the work area method. And those requirements are much more specific, have a lot more different exceptions or different levels of compliance that get triggered for existing buildings. Essentially, there's kind of 3 levels of work for a renovation project. Level 1 is you're not reconfiguring space. Level 2 would be you're reconfiguring space, adding new systems, etc. And then a level 3 alteration is where you essentially reconfigure more than 50% of the building area. And the way the work area method works is that each level kind of grows on each other. So if you have a level 2 project, it has to comply with level 1 and level 2 requirements, and then level 3 need to comply with levels 1, 2, and 3 requirements throughout the existing building code. Like I said, where this is the most beneficial is it's much more specific to what you need to do and to what level of compliance with the code for new construction, or even specific exceptions of when you need to provide certain systems or certain things within the existing building. So we find that to be the most beneficial. And then the last option is the performance compliance method. And I would say, in the various years that we've been using some form of the IEBC, or even, in some other states that use BOCA that had a similar point scoring method, we very, very rarely used it. We found that you need to essentially exceed the code for new construction in one area significantly to make up for lacking in other areas. So essentially it's a trade-off option. We have used it a handful of times, and it has worked a couple times in terms of scoring a building. There's, I think, 18 different categories. Each one could become a debate with the building inspector. So like I said, we found that it's kind of a last resort, but in some cases it has been useful. And then in Massachusetts, regardless of which of the above options you use, there are certain Mass unique requirements that would apply no matter what method is chosen. And that would potentially trigger either compliance or minimum levels of safety within the building, such as there's minimum lighting and ventilation, minimum egress requirements that essentially a building official could cite at any point for an existing building. And obviously, once you do a renovation project and pull a permit, that may make the building official aware of some non-compliant issues in the existing building that would have to be brought into compliance. And again, those are generally, clear-cut life safety or health safety issues such as poor ventilation, lack of proper egress, you only have one means of egress where you need two, or it's blocked, or something of that nature. Certainly with a lab building, but any renovation project, you're required to submit a building investigation and evaluation report, generally previously referred to certainly as a Chapter 34 report. I think I've heard it both ways a little bit more frequently now, but essentially it's a code report that's, given as part of the permit submission, and it essentially details and provides an evaluation of essentially why your project meets the existing building code. Obviously, it's much more important now that the IEBC is in effect, because it defines, first of all, which method did you choose to utilize to comply with, and then it steps through that method to show how the building, does comply with the existing building code. So, it's a good tool for everybody. It obviously gives the design team the information they need to do the project, but it also gives the building official, a lot of information, so they can determine or understand why, for example, if you're not adding a sprinkler system, here's the code section that would have required it, and this is why we didn't reach the trigger, or some other things. So I think we found that most building departments at this point have, require some form of code report for existing buildings, and certainly for a lab related project, I would say most officials are going to certainly look for that, just so they have some kind of idea of, is it changing use to a high hazard? How are the chemicals being handled? We within control areas? Are you doing proper ventilation? Items like that. So I think certainly if it's not required for all projects, I would certainly anticipate the building and fire officials looking for a report of this nature for any existing building that's dealing with labs and certainly hazardous materials. So kind of jumping in, we've done, like I said, a bunch of these existing building lab, either conversions or just renovations over the last couple of years. So some of the big things that we've seen for existing lab buildings that are just being renovated, obviously you have to maintain the same level of protection and same level of compliance as the building exists before you do the renovation. And then when you're doing your new work, you certainly need to, and again, this is where that evaluation report comes in, document, we increasing the amount of chemical storage? Are we maintaining the control area separation, or was the building one big control area and we're staying below the maximum allowed quantities? Are we changing use to a use group H space, or do we have to add in, a high hazard storage room, for example, because the tenant now needs more chemicals than they anticipated 2 or 3 years ago? So that's all, important stuff that would be documented in that report. And then, the other thing to keep in mind, changes, to operation. You weren't dispensing, and now you're dispensing within a room, or, you had an open lab that didn't really use any flammable combustibles, and now they're using that for their operations. Do we need to worry about the electrical classification of the equipment within the space, because now we have a, potential explosive environment, or, do we need to increase ventilation because of the operations that are happening? So those are some of the big points that we, have seen at least questioned or need to be addressed as part of, a lab building renovation. And like I said, we've been seeing more office buildings being converted to lab buildings. And, again, as you would do that, you'd certainly evaluate the building for chemical storage. So again, is this going to be more of a bio lab building, or is it going to be a chemistry heavy lab building? Do we need multiple control areas? A lot of the cases we're finding that the buildings don't have fire rated floors, for example, so they don't necessarily lend themselves to having, multiple control areas or control areas on upper floors. And then certainly the electrical and HVAC systems generally probably would not be appropriate for, for example, flammable, combustible liquids, for example, or gases where, you'd be dispensing them in a room or have the potential for a leak that would create an explosive environment. So those are probably the bigger items with respect to converting is really, is the floors rated? How would we do control areas? You know, what kind of tenants are you trying to attract? You know, if it's more bio based and you don't need a lot of chemicals, then maybe it's not a big deal. But you know, other buildings, like I said, you know, how hard is it to retrofit fire rated floors? You know, including the supporting construction. So those are all important things to keep in mind as you're looking at existing buildings, either again renovating for labs or, you know, converting to lab space. And then the other big item, again, with any existing building project, but you know, and it still applies to lab buildings, is the Mass Architectural Access Board requirements for renovations of existing buildings. As I'm sure most of you are aware, the MAV doesn't apply to office areas or employee-only areas. But they would still apply to, say, a multi-tenant building or something else of that nature within like the landlord space or the building owner space. So the main triggers is if you're spending over $100,000, you need an accessible entrance. If you're if you're over $100,000, it's accessible entrance, toilet room, you know, public phones if you have them, they've kind of gone out, and then any public shared toilet rooms. And then the big trigger, obviously, again, I'm sure if you were existing building in Massachusetts, is a 30% trigger where where the project cost exceeds 30% of the assessed building value. Now you've triggered full compliance throughout the building. And we've certainly reached that threshold on most of our lab conversion projects for an existing building, because obviously, you know, open office space doesn't, you know, work as lab space. So obviously doing pretty significant renovations, and if you're doing the entire building, it's not hard to get over 30% of the assessed value in most of these places. And where we've seen it affect it the most, again, is because 521 CMR would not apply within like the tenant space or the office space where it's employee only, but it would apply to the landlord building owner spaces, such as the main lobby, all the entrances, your exit stairs. So that's handrails, nosings. So any of those common area, the bathrooms, so anything that's shared is essentially considered public space, even though it's only employees of the tenants that are in the building. Once it's shared by multiple tenants in its landlord or building owner space, that would fall into the jurisdiction of the Mass Access Board. And then the only obvious other thing to keep in mind as you're doing work even in a building that's employee only or generally not subject to 521 CMR is the ADA still obviously always applies as a federal standard. And that generally kind of requires your new work to be accessible. So that would be, again, any bathrooms within your tenant space, any common staff lounges, any kind of common space within the tenant space would have to be accessible if it's new. But individual work areas, your lab benches, your offices, your desks, those do not need to be accessible per the ADA. So that's, again, kind of a brief overview of some of the stuff we've seen with existing building conversions and some of the items. So now, I don't know if you want to, if there are any questions on that. If not, we'll jump into the requirements generally for a lab building. So these would apply to any new lab building, or, you know, if you're doing work in an existing building or an existing lab building, these would apply to like any areas where you're doing new work or renovating or changing your chemicals or anything of that nature. So generally, hazardous materials, kind of two main categories. You know, one's a fire safety or fire hazard, and then the other one would be more of a health hazard. And essentially, the IBC has that two different tables that are split into those two different hazards. So, you know, a fire hazard would be, you know, kind of the obvious flammable liquids, solids, combustible liquids, you know, explosives, gases, etc. You know, and then you get into some of the more specialized ones: oxidizers, pyrophorics, unstable reactives, water reactives. And then for health concerns, there's corrosive, highly toxic, and toxic, and they all have different thresholds and different methods of, you know, determining, you know, based on either flash point or items like that, or, you know, corrosive, highly toxic, ELD 50s, and etc. And, you know, those are all kind of defined in Chapter 2 of the IBC in terms of determining, you know, what category does that hazardous material, what is that chemical classified as? And then, as you'll see later on in the presentation, those classifications will determine how much of that material you can have before you become a high hazard use within the building. So as part of the definitions and classification of hazardous materials, in terms of day-to-day usage, or even when you're doing an evaluation of an existing building, and certainly the fire department's very interested in, what's in these buildings, what's in the spaces, and how do we properly label them. So both the ICC and NFPA require that, some of these spaces or buildings or areas be essentially placarded or provided with signage that follow the NFPA 704 diamond requirements. So, as you can see here, there's, 1/4 of it is for health, fire, reactivity, and then kind of a special hazard. So within those diamonds, you would essentially put a number in. The higher the number, the more hazardous the item is. So like for fire, rating of 0 does not burn under normal conditions. And then as it makes its way through, it gets all the way up to, a class 1A, highly flammable type material. Health hazard, again, 0 is no hazard, all the way to, health hazard of 4, could cause death, just by being exposed to the chemical. So, so essentially the diamond just gives you, it doesn't give you necessarily specifically what the hazard is or what the material is, or, even what some of these flash points or, boiling points or anything of the value, but it gives you an idea of, how dangerous the room is or the area is. And again, it's more of a guidance than necessarily a way that you would determine the use group classification or anything else with the building code. When you're doing, evaluating of the building, or you're doing your design for, building code compliance, there's kind of 3 main categories that we see typically: labs or, chemical use type buildings for research purposes and teaching. Is, use group B is, business use. So essentially you're below the maximum allowed quantities. You're not a high hazard use group. You may or may not have control areas depending upon what about the total quantity you're going to store in the building. And use group B also includes colleges and, universities, essentially above the 12th grade educational purposes. That would also be use group B. So that's obviously the vast majority of laboratory buildings, and certainly you don't typically have use group H laboratory buildings. You may have portions of the building that are use group H, but most laboratory buildings, you'll see your use group B, which is office space with lab space. And then in most laboratory buildings, or in quite a few anyway, we see a lot of them have like a use group H area, or an H3 storage room, which would be flammable combustible liquids over the maximum allowed quantities. And these would be limited to generally under 500 square feet, or relatively small storage rooms or waste rooms, where you would exceed the control area limits for quantities, but you don't want to necessarily trigger the very stringent use group H requirements throughout your building. So you would do a separated use, and you comply with the use group H requirements only in that area, or the the egress serving that area. And then the final type of building that obviously has some form of chemicals, but generally are definitely well below the maximum allowed quantities, is use group E, which is schools K through 12. So your science labs and your chemistry labs and stuff. And again, typical schools don't have that larger quantity, so we don't see, usually it's one big control area of the whole building's under the maximum allowed quantities. Under NFPA, the classifications are generally an industrial type building. So again, that would be a manufacturing type space. Use group business or use group B, again, those are mostly more often than not, that's what the lab buildings are. And then, use group E is educational. And so when you look through the NFPA standards, they don't obviously have the same use group classifications and designations as the international codes. So like I said, they kind of correspond to industrials, use group H, or, a higher hazard than business would be labs, and education corresponds to use group E. So within the building code and NFPA 30 as well, and if you look at the mass amendments, they actually amend in 527 CMR, they amend NFPA 1 to at least attempt to try to match up these maximum allowed quantities between the International Building Code and essentially NFPA 30. So the maximum allowed quantities are essentially a small amount. It's and building would remain classified as the primary use group. So again, if it's off, just basic office, it's use group B. Business, the entire building would be use group B. If you have more than just that small amount that's below the maximum allowed quantity throughout the building, you can divide your building up into control areas. So again, your building would still stay kind of that primary use group or use group B. And your building would have to have 2-hour floors generally, 1-hour walls or 2-hour walls, depending on how tall your building is and where the control area is located. And then when you divide your building up into these control areas, each control area is allowed to have a certain percentage of the maximum allowed quantity. So, if your building exceeds the 100% throughout, now, when you get to the control areas, you can have more of them, and each control area can have a certain amount based on its location. And then where you exceed those maximum allowed quantities, you would have a high hazard or use group H occupancy. And again, typically you don't see the building classified as that because it is pretty stringent, and the construction type, et cetera, would have to be much more robust than if you just called it a business building. So normally we would see a storage room or a storage area carved out as use group H. And only that area would comply with the more stringent requirements. So when we talk about excuse me, maximum allowed quantities, in the table, this is just a partial excerpt from the IBC. The table obviously has a lot more different material classifications, and there's another table that has the health hazard limits. But when you look at this, for flammable liquids, even class 1, B, and C, you're allowed up to 120 gallons, and then you can increase that by 100% if the building's fully sprinklered. So these maximum allowed quantities are, a decent amount depending on the type of chemical. Obviously, the more hazardous, such like, an unstable reactive, class 3 or class 2, at 60 gallons or 60 pounds or 50 pounds in a sprinkler building, you can go up to 100. So, so it does get limited based on the classification. And as you can see on the next slide, we're talking about control areas, those percentages, you only get a percentage of those as you go up in the building. So, those previous maximum allowed quantities, you can essentially divide. So here's an example, or of what the code allows for maximum allowed quantities and control areas within your building. So, for example, if you had a 5-story building, all your floors would need to be 2-hour rated. You could divide it up into separate control areas. And within each floor, for example, floor 1, you can have 4 control areas, each with 100%. So you can see how those maximum allowed quantities, can certainly, add up. So, even if it's 100 gallons, for example, of class 1, and you had 4 different control areas, you could put that 100 gallons in each one of the 4 control areas. And then you could put 75 gallons in each one of the floor 2 control areas. And you can see how a lab building can have quite a bit of hazardous materials without actually becoming a use group H occupancy. And as you can see in the 4th column, it talks about the wall ratings. So up to the 3rd floor, you can actually have 1-hour separations for your walls. And once you're on the 4th floor and above, you would need 2-hour fire barriers to separate control areas and create, separate control areas on that floor. And obviously, if you're doing a lab building, you want to keep the chemicals and chemistry heavy lab type tenants or lab spaces lower in the building, because the maximum allowed quantity percentages are much higher. And as you work up through the building, for example, if you only had 100, if you're allowed 100 gallons, for example, you'd only be allowed 5 gallons on the 9th floor. So you're pretty limited once you get up in the building. But the lower levels certainly can have quite a bit of materials and quantity on those levels. So like I said, it's certainly with existing buildings, this is one of the more critical things to investigate as you're working and evaluating the building and trying to determine if it is feasible to convert your building to a lab building. So the general requirement is you need the 2-hour rated floors to be able to have multiple control areas within the building. The only exception to that is in essentially a 1-hour fire rated structure that's only 3 stories in height, that's fully sprinklered. The 1-hour structure would be sufficient. Other than that, you would need the 2-hour floors. So what we've done on a couple projects where the existing building didn't have fire rated floors, and it was, would be cost prohibitive and difficult to retrofit fire rated floors, is to essentially create boxes. Like in one project, we're doing it in the basement, so it's on grade, so we don't have to worry about rating the floors. We just do a 2-hour cover cap or ceiling, supported by the 2-hour perimeter walls around the control area. And that actually, we didn't have to touch the existing building construction at all. And since the walls were supporting the 2-hour fire rated horizontal assembly, the new walls and the new horizontal assembly were fire rated, and we could put a control area on the lower level without having to affect the whole building, which allowed more chemicals on that level or within that tenant space. And then the rest of the building is limited to just the maximum allowed quantities throughout the building. So that's one option. We've also seen it where you kind of carve out maybe a wing of the building and you stack your control areas. And you can do all the supporting construction, you can do the rated floors and stuff just in that small portion. And then the remainder of the building becomes one large control area. And then you use kind of that wing or that carved out area that's stacked as multiple control areas. So there's a few different options. But it is critical when you're evaluating and looking at these existing buildings to try to determine what do you need for control areas, how many, and what's the easiest way to try to fire retroactively or go back and fire rate the structure to achieve the required fire separation and structural requirements for control areas. When you're above the maximum allowed quantities, essentially you're creating kind of a use group H or the high hazard area, and you have to comply with NFPA 30 as well. One of the limiting factors that we found is NFPA 30. If you go over 500 square feet, we would require essentially your storage room or your storage area to be considered what they call a liquid warehouse, which requires 4-hour fire rated wall ceilings and floors. So generally, we find that obviously to be very cumbersome and difficult to meet, because certainly it's very unlikely any existing building for sure has 4-hour structure to support that type of space. And even in a new building, 4 hours is not a very common fire rating. So generally we see kind of these.
Don?
Oh, yep, go ahead, Drake.
Hey, Don, can I ask a question?
Absolutely.
Going back to the issue of the fire rating for the floor area.
Yep.
Does that fire rating have to then carry down through the structure all the way to the foundation?
Yes, absolutely. So anything that's supporting those rated floors and rated control area walls all have to have the same rating. So that's where it gets difficult in an existing building. If you wanted to do the entire building as multiple control areas, now you're having to go back and, if it's wood framed, certainly you can't really even get to 2 hours, or it's very difficult to achieve 2 hours. Obviously, you can always structural steel and concrete, you can spray the building, but the rating would have to carry all the way down through the building, all supporting construction, all the way from the foundation to that kind of highest 2-hour floor assembly that's creating your control area separations.
Yeah, that's an issue that is often missed by those who are not familiar with this process.
Right. Yeah. I think that, you look at the building and, it's already use group B, will stay below the maximum allowed quantities, which, it sounds good, but, even in the couple of projects, we brought it up at the beginning, and then about halfway through, 3/4 of the way through, the building owner starts talking to some tenants, and they, most lab tenants know the control area concept and don't want to be, significantly limited to chemicals. And then they kind of change their mind halfway through and say, we talked to a couple of tenants and they want to know how many control areas they can have, or how, so we've definitely seen this come up later on in a project, even where, it sounded good at the beginning before they had tenants, and then once they start talking to tenants, they realize, oh, we may need some control areas, or maybe we have to look at the lower level to create some of these storage rooms or something else of that nature to retrofit it. So I don't know if it's necessarily overlooked as much as it's the assumption at the beginning is we're going to be a bio lab building. We don't need a lot of chemicals, and they do add up a little faster than you would anticipate. And I think you significantly limit the tenants you can, go after if you don't try to at least incorporate some level of control areas or kind of look at the chemical storage on the lower levels at a minimum. And again, I think it's important to keep it on the lower level if you need them, because it limits how much of that structure you need to go back and try to fire rate. So again, kind of back to the liquid storage room. So what we find is that most of these use group H spaces, or kind of these large storage rooms of larger quantities, would be under 500 square feet. That way you can have a 2-hour rating, and that essentially corresponds and meets the IBC. So most cases we find that our use group H, or our high hazard type uses, are H3, which are flammable liquids, systems that are under 15 psi. So essentially you don't have pressurized hazardous materials. And again, there's exceptions in the building code that make that 500 square feet pretty important, because the building code has requirements that these rooms be located in certain portions of the building, or away from lot lines, or along the perimeter of the building. So it's important to kind of know, one, what use group classification are you in, and then how big is that room going to be. So for example, if you have a high hazard room, again, usually it's a use group B building. I mean, you could have it in a larger use group B school system, but normally you find it in use group B. So H3 actually only requires a 1-hour fire rated separation. H2 is the pressurized chemical. So if you did have a system where say you had a storage tank of a flammable liquid and it was piped and pumped into an adjacent lab area and it was at a higher pressure, that potentially would trigger use group H2, which would be a 2-hour room. But even with that, you're most likely need to be 2 hours anyway if you're over the 150 square feet per NFPA 30. So you got to kind of work together between the two codes. I would say hazardous materials are one of the more frustrating parts of the codes, because there is two, three, maybe even 4 different codes or 5 different codes that all impact how you design it. Being the building code, obviously, the International Fire Code, we're referenced by the building code. Then you have NFPA 1, which NFPA 30 and 45 are adopted, depending on how you're storing your chemicals and how you divide up your building. And then obviously there's the mechanical code that kicks in as well. So it does get quite complicated, and you have to obviously meet all the codes. So essentially up to 150 square feet, use group H3, you can be 1-hour rated. Over 150 square feet, under 500 square feet, you can be 2-hour rated. And then generally nobody does anything over the 500 square feet. So as I was saying, depending on your use group classification in the building code, there are minimum separation distances for walls that enclose that occupancy. So for H2 and H3, there is no requirement, or for H3, there is no requirement, again, which is the more common requirement, more common use group classification, I should say, for these type of hazardous or chemical storage rooms in a building that has control areas. If you do have that use group H2, where it's pressurized system or flammable gases, if the aggregate area exceeds 1,000 square feet, again, now we're looking at a 4-hour rated room. You have to be 30 feet from a lot line, which again, a lot of these buildings, are on larger parcels, but obviously in downtown Boston, you see plenty of these lab, down in the seaport that are, high-rise lab buildings that essentially take up the full lot, or may not have the full 30 feet. And then the other criteria, and this is where the 500 square feet also comes in pretty importantly, is if you exceed that 500 square feet, you also need to be along the perimeter of the building. So 25% of your room needs to be along, or that use needs to be along the perimeter of the building. So that gets problematic for sure, especially again in these lab buildings where you don't want to be putting a storage room along the perimeter with all the nice glass walls and windows. You want that to be your lab and office space. So that's again another important aspect of where the 500 square foot kind of limit for those storage rooms come in. So kind of now jumping more into specific systems and means of protection within these rooms. The code requires, go ahead.
Don,
Yes,
one more question.
sure.
On those storage rooms, you didn't make any mention of the possibility of use of blowout panels.
Yeah, I have a couple slides on the explosion control later on, but
Right.
yeah, so that's also part of the reason for it to be on the perimeter, but there are other systems out there that you can use to essentially prevent the explosion or, other means. So when you have it internal to the building, and it's only certain chemicals and certain hazardous materials that actually require the explosion control. So that's why, again, it being located on the perimeter of the building is not as important necessarily. But yeah, we'll touch on the explosion in a little bit. But so as part of the leak detection requirements, so again, a lot of these requirements now that are specific, that have the enhanced protection are generally required in these use group H or, liquid storage room spaces. So when you look at it, a lot of them will say, where the storage is over the maximum allowed quantities or where the containers are over the maximum allowed quantities, items of that nature. Items like that. So you would, if you're below the maximum allowed quantities, most of these requirements don't apply, which is again why a lot of these lab buildings are using control areas or trying to limit the quantities. So in terms of, we have storage of flammable combustible liquid tanks over the maximum allowed quantity. You need, leak detection in the room. Where you have hazardous production manufacturing facility, and you have gases over, certain warning levels, flammable gases in the fabrication area, HPM rooms, gas cabinets. So this is more in like a manufacturing facility where, you're using hazardous materials to chip manufacturers, generally use a lot of hazardous materials to actually produce the chips, but the actual item that's produced is not hazardous. That's what HPM generally covers. So you need gas detection in those type of facilities. So that's kind of the building code requirements. And like I said, then there's the international fire code requirements that require leak detection. Again, where you have health hazards. So, class 3 or 4, flammability, class 4. So the more higher hazard materials, the international fire code requires some kind of leak detection where you have pressurized systems. And then underground flammable combustible liquid storage tanks would have to have some leak detection for generally for environmental purposes than actual fire hazard purposes. But and that again corresponds to or is also addressed in various NFPA standards. So we have compressed gas vaults, flammable combustible liquid vaults. So those are again more of those 4-hour type high hazard spaces. You need certain vapor and liquid detection. And then hydrogen fuel gas rooms, you would need flammable gas detection. Some other gas, toxic gases over the MAQ and cabinets, exhausted enclosures, toxic and highly toxic gases over the MAQ. And then, corrosives in gas cabinets. So again, a lot of when you're over the MAQs and a lot of very specific requirements for detection. And again, so these, again, that's NFPA 1 and NFPA 55. So as you can see, the IFC has their own toxic, and then NFPA 1 has corrosive gas requirements. So as you're going through, it's it's very important to, one, know which code you're falling under. Are we above the maximum allowed quantities? And part of the hardest part of this, especially when you're doing the design of kind of the shell core before you have the tenants, is how do you kind of determine when do you need some of these systems, because they are so dependent on the type of materials, the quantity of materials. And if you're trying to design, a lab building to handle anything, you potentially be adding in a lot of different systems that you may not need once the tenants are found. So it becomes challenging in some cases if you're not designing the building specifically for a certain tenant or a certain occupant who has a good knowledge of what chemicals and how many chemicals are going to be putting in your building. Generally, we take the approach, or we've seen the approach that, we either, generally we do control areas. We'll define how many control areas per floor, but we don't assume any use group H spaces. We don't necessarily design for use group H spaces. But because they only need to be 1 or 2 hour rated anyway, they're pretty easy to retrofit into a building that is already designed for control areas, because you have the fire rated structure, you have the fire rated systems, the floors. So normally if we're doing shell core or kind of the start of a lab building or even a conversion, that's just the general concept that we take. And then these systems would be kind of TI produced, or, we provide what infrastructure we can, such as shafts or other items. But, this becomes more TI type detailed stuff. And, and it really does start with the quantity of chemicals, where do they want to store them, and the type of chemicals.
Hey, John, before you move on, we had a
Sure.
question in the chat. So how do you protect the means, like, for example, the pipes, to move the hazardous liquids to other rooms or outside of the building? Is there any guidance on protecting the actual sort of transmission lines?
Honestly, there really isn't. That is kind of a challenge. So normally, essentially, the pipes have such a minimal amount, so you would protect the rooms, and then you would just either fire stop the penetrations, and then everything outside. So say you have that liquid storage room, or you do a storage room that's a separate control area that's 1 or 2 hours separated from the rest of the building. You kind of fire stop that penetration, and then you kind of start over. And the pipes usually aren't considered the main hazard, but obviously if you do have those pipes and it's pressurized in those rooms, and if it, again, this is where it kind of gets into open use versus closed use and the quantities, but generally it's just the room where the actual material is stored gets most of the protection, and you pipe it into the control areas. And there are generally allowances or exceptions for the piping in the piped portion of the system.
Great, thank you.
So one of the bigger items that's very important to evaluate or analyze, or look at early on, is when you need spill containment, and certainly the secondary containment. So generally you always need kind of spill containment for the largest vessel in a room, to just keep it from even if it's use group B, you want to obviously maintain, if there is a spill, keep it to that room and don't let it spread outside of the area. So that's either done with berms at the door, or even pallets that have integral storage and containment within them. Once you exceed those maximum allowed quantities, and if you're use group H, then you got to look at a little bit more closely at it, because if you have a use group H over the maximum allowed quantities, and you have hazardous liquids in containers greater than 55 gallons or 1,000 gallons aggregate within the room, essentially you need what they call secondary spill containment, which has to be sized for the largest vessel, plus 20 minutes of sprinkler water flow. And as you can imagine, now you're in a higher hazard room with chemicals, so your sprinkler water flow has to be higher than, say, an general office area. Those storage tanks for that capacity can get pretty large. So now you're looking at a floor drain into a storage tank, or a pretty significant system that you certainly need to design for and accommodate within your building. So this is, again, where the codes, I wouldn't say conflict, but have different requirements based on the type of material. So again, for use group H, containing flammable hazardous flammable and combustible liquids, if again, a single container is 55 gallons or more, or you have 1,000 gallons total, you trigger this kind of secondary spill containment. NFPA 30 has its own requirement. And that's when an individual container exceeds 10 gallons. So again, so this is a much more stringent requirement and would also be applicable. So the only time it wouldn't apply is if you have a class 3B liquid, which is generally not limited in quantity anyway, once you're in a sprinkler building. So generally class 3B would never trigger your high hazard use, but as you can see, it's important to make sure you're looking at every code and all the different applicable codes, because they have different thresholds for a lot of these systems. So again, you have to have a drainage system or some other way to control the sprinkler from water spread. And then, in some cases, we're working on right now an existing building where they want to make their use group H space larger. And to do that, they had a foam system in there. We're going to just expand the foam system to protect the space and not have to necessarily be concerned with this spill containment requirement of NFPA 30. So with the different requirements, there are different methods of compliance. So again, for that spill containment, you could do a foam system, which essentially kind of coats the top of, the flammable combustible liquid and essentially smothers and prevents the fire from even starting. And another system where, again, you can have multiple different means of protecting is explosion control. So it's required in use group H areas, again, over the MAQ, where an explosive environment can occur because of the hazardous materials, dispensed or being used. So generally, it can kind of consist of one of three options. One would be the explosion venting. So that would be the blowout panel. So obviously your building would have to be on the exterior, your room or area would have to be on the exterior of the building. The explosion prevention system. So that's more of a detection system that would detect a fire, and essentially suppress it before it actually becomes explosive, or, enhanced ventilation, enhanced sensors, detection of, levels of explosiveness in the LELs or, the vapors. And then damage limited construction is essentially you've designed your room to contain, or your space to contain the explosion. So obviously that would be a very structurally, strengthened and strong type of space. Generally, we see that damage limiting construction like more of a partial type concept, where it gets incorporated with the part of the explosion venting would be you'd reinforce a couple of the walls, and then it would force the vent out the explosion to vent out the weaker portion of the building. But there is an allowance to actually reinforce and make your room so strong that it would actually contain the explosion. So the explosion venting or prevention system, again, is required when you store it above the exempt limits. So for certain chemicals, so for flammable liquids, example, class 1A would be required, and class 1B is only required when you have open use or dispensing of that material. And then essentially a class 1C, class 2, or anything of a lower flammable or combustible liquids would not require explosion venting. So again, it's very specific chemicals. This is where it's important to understand what's being stored in the room and how it's being used to determine what systems are needed. It's very rare that we find explosion venting and explosion control required in most lab buildings. There's essentially you can operationally store chemicals and use them in a manner that doesn't trigger compliance with this. But similar to before, NFPA 30 kicks in again when you're over the maximum allowed quantities, and that would actually require, if you had a 1 gallon container of class 1A or an unstable flammable liquid storage room. So, NFPA 30 would kick in with slightly different thresholds. Interestingly enough, though, for some reason, and I've never really kind of understood this, but NFPA 30 says liquid storage rooms totally enclosed within a building are exempt from this requirement, because obviously you can't necessarily do explosion venting if it's on the inside of the building, but they don't require you to put it on the outside. So essentially, if you put it on the inside, you've met an exemption, not because you are safer, just because there's no physical way of doing it, which was always kind of perplexing to me. But by essentially the combination of the building code and NFPA 30 and everything else, you would kind of get there if you reach some of these thresholds over the maximum allowed quantities anyway. In a lab building, NFPA 1, references and adopts NFPA 45, which is a very similar concept to the control area concept, but it does obviously have different requirements and limitations than what the IBC has. So it's similar in the fact that you can divide your building up into separate kind of fire areas. In this case, they're called laboratory units instead of control areas. In the building code, there's no area limitation for your lab units. And in the building code, there's no different, I guess, classifications for control areas. It's either you're below the maximum allowed quantities or you're not. So you're either control area or you're use group H. Under NFPA 45, they have different laboratory units, which is based on, I'll show you on the next slide, is based on the amount of chemicals as well as the density that's being stored within this space. So obviously laboratory unit A would have the highest hazard all the way down to laboratory unit D, which essentially has the least amount of chemicals and the least dense chemicals. And then within there, and then the other difference between NFPA 45 and the building code is they don't limit the number of lab units. So you can have, many more lab units than control areas, as long as you meet the size limits and the fire rated separations. So to determine your hazard ratings of your lab units, you look at the quantities. Again, it's maximum quantity in the lab unit, and then it's the maximum quantity, essentially kind of the density. So it's we have the metric units in here, but per square meter, per square foot of laboratory unit, you can have 38 liters, and then the maximum quantity within the entire lab unit, you can have 1820. So it kind of caps not only the maximum quantity, but the density of the storage within the unit, within the laboratory unit. And again, these quantities differ from the building code quantities in terms of, the overall amount you can have. So, in cases where the laboratory unit quantity is less than the building code quantity, you could put multiple lab units within your control area and, meet both codes in that manner. So some of the further limitations of NFPA 45, so for like educational laboratories, K through 12, they only allow certain classifications, essentially Class D or Class C, up to 50% of the allowed Class C quantities. In the educational labs have to be 1 hour separated from the non-lab portions of the school. For colleges, they can only be Class C or D. You can't have the higher hazard Class B, A or B lab units within those types because they're considered, the users aren't as familiar with it and, don't have as much experience dealing with some of these chemicals. So, they try to limit the potential hazards that could be created. Some of the other differences between 45 and the IBC in terms of that, 45 references NFPA 101. In general, Mass kind of doesn't require compliance with NFPA 101 because the building code covers all the means of egress requirements specifically that are covered by 101. So in general, the egress requirements would still follow the building code for the most part, but there is the reference. So we have seen, some complications caused by that. But specific in 45, there are the single exit requirements, which we certainly have seen enforced by, the fire officials. And it does limit the maximum size of some of these of the lab units that can have a single means of egress out of the unit. So you might find that, you meet the building code, under 50 people, 100 100-foot travel distance, but you may not meet NFPA 45. We've had it go both ways. We've had discussions with the building and fire officials and said, the intent of the Mass Code and the fire code is not to contradict the building code in terms of means of egress. That the building code is really supposed to dictate that. But there have been a few instances where the building and fire officials have enforced the more stringent NFPA 45 requirements. Again, in my opinion, the building code is supposed to kind of supersede the fire code in terms of building construction requirements, but that has been a jurisdictional battle for probably decades at this point in terms of what code supersedes what and who has authority over certain aspects of the code. And this requirement for standpipes would be a similar requirement that, the building code wouldn't necessarily require standpipes in a 2-story building where 45 would require that. So one of the another system that's also can become confusing and has caused issues in the past is hazardous exhaust, and how do you exhaust these lab spaces and fume hoods and items of that nature. So hazardous exhaust is essentially required anywhere you could exceed some LELs or some other criteria without the presence of the exhaust system. So for hazardous exhaust, the mechanical exhaust of high concentrations, again, of dust or hazardous vapors have to comply with 510. And then within 510, there are a lot of exceptions for laboratory buildings. And that's extremely important because if you don't meet the laboratory requirements, you certainly would trigger additional systems or additional protections that aren't normally provided. So this allowance is very important. And I think most people are pretty familiar with the laboratory classifications in terms of hazardous exhaust, but it does result in a lot of important exceptions. So a hazardous exhaust system is required wherever the absence of the system would require you to have flammable vapors over 25% of the lower flammable limit, a health hazard issue, or a health hazard concentration 1% of the medium lethal dose, or a health hazard rating of 4. So essentially what this is saying is if you don't have that system, would you create a hazardous condition? So essentially that system by default must be exhausting something that is of a higher hazard that needs to be addressed specifically per the code. Otherwise it would be diluted to the point without the exhaust system that it's not truly a hazard. So hazardous exhaust lab requirements, and again, it's important to note the lab requirements because it's different if this was like a manufacturing facility or a facility that was using, either producing chemicals or using chemicals to produce items or a manufacturing process. That's treated completely different than a lab building. So in all buildings, the code requires that the hazardous exhaust system be independent of other exhaust systems. So essentially your fume hood exhaust cannot manifold together with the room exhaust unless the room exhaust is also considered, hazardous exhaust. So, you can't, so say your general exhaust system, your general ventilation system serves the office area, serves all these other spaces. You couldn't manifold or connect your fume hood exhaust to that exhaust system. And then your hazardous exhaust system also has to be in its own shaft, independent of these other systems, unless you do essentially a subduct system, which essentially is all the duct work is under negative pressure. It's a continuously operating fan. The fan's on emergency power. And then you can put multiple ducts in the same shaft, but your hazardous exhaust ductwork still needs to be completely separate from all your other general ductwork and your general ventilation ductwork. And then that hazardous exhaust would be constantly ventilated, and because you can't have dampers, you have to subduct, which is essentially a 22-inch duct that enters into the main exhaust duct and travels vertically up 22 inches, and that kind of prevents, if there ever is a problem in that ductwork, from by having the negative ventilation or the negative pressure and the constant exhaust and constant ventilation with the 22-inch upturn prevents fire and smoke from spreading between floors and entering the floors above, or, you know, by having the ventilation, you obviously prevent the exhaust, the smoke and everything from filling back down into the shaft and spreading to other floors. One of the more important exemptions, and this is where the laboratory classification is you do not need a suppression system, you know, sprinklers within the ductwork. So for laboratories, this isn't required. Again, that's where it comes in, you know, the laboratory designation versus a manufacturing facility, for example, would, you know, is very important with this type of system. As I just noted, you can't have fire and smoke dampers within that exhaust system because the whole point is to exhaust that, and you wouldn't want those closing or shutting under smoke or fire conditions. You actually want to try to exhaust that and, you know, keep the place safe by exhausting the smoke and whatnot. So so what happens is, say you don't have obviously a shaft in every control area, or, you know, for some reason you have other fire rated walls dividing your floor. Once that ductwork penetrates that fire rated wall, you either need to wrap the ductwork in a rated enclosure, or in that case, or the alternative is to actually provide that interior duct fire suppression system. So normally we see, you know, the ductwork enclosed in some kind of fire rated assembly, or, you know, if approved by the building official, duct wrap or some other kind of means of creating that fire rated separation and maintaining it from essentially that wall penetration all the way till you reach the duct, all the way till you reach your shaft. And then once you enter the shaft, you can combine your ductwork in the shaft into that common exhaust riser that serves your other hazardous exhaust systems throughout the building. Electrical systems. So again, depending on the materials that you're using in the space, whether or not you have an explosive environment while you're working on it, or whether or not it would only happen under an accident, you do need to worry about your electrical systems and the classification for them. So within NFPA 30, and I believe it's NFPA 497, there are different requirements for classification. But within NFPA 70 itself, it's got kind of a vague description and definition for when you need to classify your system. So essentially a class 1 division 1 requirement applies where vapors exist under normal conditions. So you have like regularly will have an explosive environment. You need to have fully explosion proof electrical equipment. Where you have flammable combustible liquids, but they're normally contained, or it's an exhausted enclosure like a fume hood, you have a class 1 division 2, which still you know, the electrical equipment still needs to be listed and tested to pass that, but it's potentially little less forgiving, or more forgiving than a class 1 division 2. And generally this would be, you know, along the floor, you know, within 3 feet of the floor within the space. You kind of need to look at that and look at your electrical requirements based on, you know, the likelihood of having explosive vapors, or, you know, even under an accident when you have it. So in a lot of cases, we would see a process engineer or some other engineer who is more familiar necessarily with the process that's happening in the space or how the chemicals are being used, you know, sort of helps dictate, you know, what hazards exist in, you know, an accidental release, you know, where would we have to worry about these kind of electrically classified areas. Your hazardous waste piping. So under the Mass Plumbing Code, you know, anything that's chemical waste, nuclear waste, deionized liquids, acids, solvents, essentially that's considered hazardous waste. And whether or not you, essentially how you treat these, how you drain these, how you have your sinks pipe, will really depend on kind of the local wastewater treatment requirements, whether or not you can do like a neutralization system, or if you have to actually just store it in a tank and have it pumped out by a hazardous materials company. You know, it should be a separate, or has to be a separate piping system, painted or marked yellow. And then again, normally it would go through a neutralized sump, and then it would, you know, the neutralized flow would then be, you know, sent to the waste system. And again, you know, obviously have to deal with the local wastewater company meet their regulations as well, which, you know, will vary based on the local jurisdiction. So kind of the last couple items is the emergency wash and eye wash systems and shower requirements. So under the Mass Plumbing Code and Fire Code, it's required in all labs, schools, colleges where there are corrosive or flammable liquids handled, chemicals are stored, and it has to have a shower, the handheld or body face wash, and, you know, trench hose, or, you know, one or more. So normally we would see a shower with the eye wash below, and that kind of covers both the Mass codes as well as the OSHA codes. Generally, they should be located as close to the main door as possible and not more than 50 feet from an experimental area. And that 50 feet essentially comes from the ANSI standards and the requirement that you be within like 10 feet, or sorry, requirement you be within 10 seconds travel to one of these systems. So the system must have 70 to 90 degree water at all times. So it has to be on a recirculation loop to maintain temperature, so you're not, you know, getting blasted in your eye or, you know, cold water. 30 gallons per minute. And then the detail, again, the details, design details should comply with the ANSI standard for these systems. OSHA essentially just requires you have an eye wash, a shower where you could have corrosive materials. And then when, again, you have to meet 10-second travel, which is, you know, 50, 55 feet. And then if the material is corrosive that you're dealing with, OSHA and the ANSI standard do not allow you to pass through a door. A door is considered an obstruction when dealing with corrosive, so you'd have to have it in each lab area before you pass through the main door. And then the final item is just kind of a requirement throughout all buildings that you generally have to have fire extinguishers, but within a lab, they have to be, you know, within 30 to 50 feet, depending on the size of the extinguisher. And then the Mass code, if you're working in an existing lab and it doesn't have those emergency wash systems, would require, you know, one of those fire blankets within the space in lieu of the emergency wash system. But obviously for a new lab building, you would provide the emergency wash system. And then we have a few slides just quickly on the NFPA, the 2021 IBC code changes and some new code changes that can be anticipated as part of the 10th edition. So for anybody who works in higher education lab buildings, so use group B, college and university, they actually added a whole new section on higher education labs, which actually results in you allowing you to have a larger amount of chemicals within the building. So within a higher ed building, you can have, you know, what they call lab suites. So within the lab suite, you can still have 100% of the maximum allowed quantity, say on floors 1 and 2. You can actually have 6 lab suites versus the 4 control areas, and you still need the 1 hour separation. So essentially this, in looking through section 428, there really aren't any additional safety requirements for the most part that differ from, you know, general use group B lab building, but I think the concept is it's more highly supervised, and, you know, normally the densities aren't there, and, you know, and it's more for teaching. So you can have a little bit larger square footages. You have more labs than necessarily like a lab building. So they actually added in this in the 2018, it was officially the code change, but in the 2021, it remained in the IBC. So for those who work in college and university, this is a little bit more lenient and would potentially allow you to, again, maintain a use group B classification with a little larger quantities of liquids. So NFPA 45 actually will be updated to the 2019 edition as well. And what they actually removed in here, similar to the control area concept, is they got rid of the square footage limits. So it'll be, you know, a similar concept to the control area concept in terms of, you know, the quantities you can have, the required separations, and, you know, the location above grade, but there is no square footage limit anymore. So it'll really be driven by the quantity of chemicals within the area. And then a few specific changes for healthcare facilities. So again, a lab or chemical labs located in a hospital has specific limitations in terms of class C or D. So again, the lower hazard laboratories would be required. You have to have manual fire alarm systems now. Again, most buildings would already have that anyway. Lecture bottle cylinders would be limited. And then again, a class 1 standpipe system. They changed it to be 30 feet, not necessarily 2-story buildings. So again, that would be actually a change that would bring it into coordination or, match up with the IBC requirement. And then one of the bigger changes that will have a pretty impact is the IMC actually removed a section that's in the 2015 that eliminates the requirement for your hazardous exhaust system to be independent of other types of exhaust systems. So this is actually more consistent with recommendations by lab consultants. And what it allows is essentially like your general lab exhaust, your room exhaust can now be manifolded with your fume hood exhaust and then brought to your hazardous exhaust duct riser, rather than having essentially to run 2 different ducts out of your control area. This has been approved in Mass in a few different circumstances under either compliance alternatives with the building official or alternative designs or variances. So that'll be a nice change in terms of giving a little bit more flexibility with the exhaust and ductwork design requirements and ventilation. And then there's another kind of tweak about how the makeup air is provided and how it's controlled. So covered quite a bit of stuff, but if there are any other questions, happy to take them.
Alrighty, and I don't see anything in the chat right now, so we'll give it a little bit more time. I will post this.
Thank you, Don. That was quite a sweeping coverage. I thank you for that.
Oh, no problem. Yeah. One hour is probably not enough to go into all the details, but tried to cover the high level points that, at least stuff to keep in mind as you're doing the design and look at. But like I said,
One thing
there's
that
so
I
many.
ran into that was, I thought interesting is I was doing a lab, I think it was at BU, and this is a research lab, not a teaching lab. And they had a lot of chemicals that were potentially combustible. And then they had a space where they had central storage. It was in the basement. The collection of those gases could be combustible, so that they had to deal with the deflagration and detonation and explosion scenarios. And what I learned from it is that the size of the space in which you have these chemicals actually determines how explosive it is.
Mm-hmm.
So if the room is bigger, it potentially is more explosive, because as the chemicals become aerosolized, they become that much more combustible, and that gives you that much more fuel that's in the air. And
Right.
So you have to actually calculate the volume of the space, not just the square footage, in order to figure out how much of a deflagration, or in our case, explosion vents that we had to provide. That one was something interesting because nobody at the safety office had ever encountered it before. So we had to learn it together.
Yeah. So with vapors and gases, there's kind of 2 different thresholds. There's the lower threshold, which below that you won't have an explosion. You don't have enough fuel for the explosion. Then you have the middle, which is obviously where the explosion can occur. And then once you exceed the higher level, you actually have too much fuel and not enough either oxygen. You don't have enough of a mixture that you can actually have an explosion either. So that the volume definitely matters. And what gets complicated, and where even determining if you're hazardous exhaust, for example, we really need to lean on like the process engineers, because essentially, how big's the room? How much is it off gassing? How much vapor is going to be created? What's the process going to be like? How's the dilution rate? There's a lot that goes along with it when you have to start looking at, is it a hazardous exhaust, or, do we have to worry about explosion control and items like that? So it does get complicated.
Hey, Don, so we have a question from the chat asking if you could please go over the NFPA 30 restrictions to below grade flammable liquid storage.
Sure. Yeah, so it's been a little while since I've looked it up. I know if you're over the maximum allowed quantities, which again, NFPA 30 generally has that, there is a limit depending on the classification. I don't know if it's just all class 1 or just 1A. I would have to look that up exactly, but yeah, there is a limit, either 1 story below grade or, certainly multiple stories below grade, where you can't have that class 1, or at least class 1, definitely class 1A, and, potentially class 1, any class 1, A, B, or C below grade. But again, that would be if you're above the maximum allowed quantities, in which case NFPA 30 would kick in.
Thank you. All righty. Well, if there are no other questions from the chat or from the audience at large, just a big thank you, Dawn, for talking us through all of this today. We appreciate you preparing this and then running through the questions. And thank you too for making your PDF and the recording available for people who weren't able to come or had to cut out early for meetings. So other codes committee updates. Next month, we're going to have Code Red in, and Jeremy Souza is going to talk through the different code related fire department access requirements. And then some of you are aware from past meetings that both Andy and I are past our 3-year co-chair term limits that the BSA has. So we had earlier asked for some interested parties to step up, ask any questions. I'm pleased to announce that we have 2 new prospective co-chairs who are going to be excellent in this role. And we're working through transition details right now, but stay tuned for further announcements. Otherwise, I've updated the chat again with the CEU link, so make use of that. And thank you for attending this morning.